This TA Tech tip will discuss fitting multiple transitions in a DSC thermogram.
At this point, NanoAnalyze has been opened, and the data and the background files have been loaded. The first step in the analysis is to subtract the background file. This is done by dragging and dropping the file into the scan blank box. Next, the data is converted into molar heat capacity units. Any changes that need to be made to the volume, concentration, or molecular weight can also be done at this time. You'll notice that when it's converted to molar heat capacity and update is pressed, that the y-axis changed to the appropriate units. From here, the temperature for the analysis is selected. This is done by dragging the mouse cursor over the conversion range that you'd like to analyze. Now that the molar heat capacity tab selections have been completed, the next step involves proceeding to the Integration Baseline tab. From the Integration Baseline tab, click the Add Baseline icon, and then select Polynomial. From here, drag the mouse cursor to create a polynomial baseline region. If the default linear baseline or first-order polynomial is not appropriate for your particular thermogram, choose a higher polynomial. For this particular data set, there are two distinct transitions. First one here, and the second one here. And each transition has its own pre and post, and then pre and post region. The baseline applied should try to best represent this character. After the baseline is applied, it is time to proceed to the Modeling tab. In the Modeling tab, first check the box Subtract Baseline. Inspect the baseline to see if the baseline applied in the previous tab is acceptable. Next, select a model. In this case, several models. 3 two-state models will be selected, and it's important that you choose the two-state scaled model. The scaling factor adds increased flexibility when fitting complex data. 3 models were selected because there are 3 apexes in the data. This visual clue, along with the knowledge that this protein has 3 domains that will unfold separately, is the reason why 3 models were chosen. In order to avoid the models getting fitted to a local minima, adjust the min and max criteria for the TMs. After this constraint is applied, the data can be fitted by clicking on the Fit Model icon. Another technique that decreases fitting time is to use the slide bar located below the variables AW, TM, and delta H. This is done by clicking or highlighting a particular line, which activates the slide bar. The slide bar then can be moved back and forth. This same technique can be used with all 3 variables. After these adjustments have been made, the data can be fitted again by clicking on the Fit Model icon. Alternatively, these values of min and max can be further constrained if needed. Now that the data has been fitted, it can be exported and shared.